Exercise 507 is about global maxima and minima. So if you look at this graph here, the domain has been limited at where x equals a and x equals b. So the global maximum is where the curve is at its absolute peak, and that's up here at point C. So the global maximum is at C. The global minimum is where the whole curve is at its absolute minimum, and that is point D. If you were asked to find the global maximum or minimum, you'd be given a y coordinate as your answer. Now, these other points, A, B, and C, we've already mentioned C, but they're each turning points on the curve. And a turning point is called a local maximum or a local minimum. It can also be called a relative maximum or a relative minimum. So the points A and C are local maxima. Maxima is plural of maximum. So C is actually a local maximum and a global maximum at the same time. And then the point B is a local minimum. Okay, so let's look at this example. We have to find the global and local maxima and minima for the curve f of x equals x to the 5 plus 3x to the 4 minus 2 on the domain minus 4 to 1. So what we need to do here is basically find any turning points and the end points for this curve. So I'm going to start by finding the end points. So all I have to do is substitute minus 4 and 1 into my original equation. So f of minus 4 equals negative 4 to the power of 5 plus 3 times minus 4 to the power of 4 minus 2. And if I put that all in my calculator, that's negative 258. Same thing with the other end, f of 1 equals 1 to the power of 5 plus 3 times 1 to the power of 4 minus 2. So 1 plus 3 minus 2, so that equals 2. Okay, now we need to also find any stationary points. So we need our derivatives. I'm going to do the first and second derivative. So the first derivative is, I'll just write the function again here so it's easy to do the derivative from here. So x to the 5 plus 3x to the 4 minus 2. So the first derivative is 5x to the 4 plus 12x cubed. The minus 2 disappears. And the second derivative, 20x cubed plus 36x squared. Okay, so let's find out where our stationary points are. So we want to know, where does the first derivative equal 0? So 5x4 plus 12x cubed equals 0. So we'll factorise out an x cubed. So 5x plus 12. So x equals 0 and x equals negative 12 on 5. So those are all our key points. Now I need to find the y coordinates for each of those as well. So let's have a look at that. So f of 0 is 0 to the power of 5 plus 3 times 0 to the power of 4 minus 2, so that's negative 2. F of negative 12 on 5 is negative 12 on 5 to the power of 5 plus 3 times negative 12 on 5 to the power of 4 minus 2. That's 17.9 to 1 decimal place. Okay, so we've got our important points there. Now, with those stationary points, we need to know if they're maximum or minimum values. Realistically, we can see it in the curve if we were to sketch it, but I'm going to just show as well. So let's do the second derivative test on 0. 0 was one of the points we found. So second derivative at 0 is 20 times 0 cubed plus 36 times 0 squared, which equals 0. So that's a possible point of inflection. So let's just do a second derivative test to find out if it is a point of inflection. So 0 something to the left of 0, I'd go negative 0.1, something to the right of 0 for my x values into the second derivative. Okay, and when I put those into the second derivative, this one comes out positive. This one, of course, comes out as 0. That one comes out positive. Concavity has not changed. It is not a point of inflection, okay? It is concave up on both sides, so it might look something like that. It's a stationary point, so it's actually a minimum. And our other one was when x equals negative 12 on 5. And when I put that into the second derivative, I get something that is negative. So that's a maximum turning point. Okay, so let's summarize what we've got here. So I'm going to put it into a little table. So we've got some important x values that have come up. So our end points were negative 4 and 1. And then we also got, the next one here is negative 12 on 5 and 0. And I've written those in order. So our y coordinates for each of those, negative 4 was negative 258. Negative 12 on 5 was 17.9. 0 gave us negative 2 and 1 gave us 2. So we can see here our absolute maximum is 17.9. Our absolute minimum is negative 258. So I'll write it out. I might actually just draw the quick sketch of it as well. So we've got negative 4, negative 258. We've got negative 12 on 5, 17. We've got 0, negative 2. And we have 1, 2. So that was our maximum. This was a minimum. It looks something like that. So we have global maximum equals 17.9. Our global or absolute minimum is equal to negative 258. So that was that point for the maximum and this point for the minimum. We also have a local minimum. Sorry. A local minimum at the point 0, negative 2, and a local maximum, which we've already mentioned. It was that 17.9. So that's negative 12 on 5, 17.9.